Welcome to this session on the rise of agentic AI, an emerging wave of artificial intelligence that is reshaping the way decisions are made across industries. Traditionally, AI systems have functioned as tools that wait for human input. But with the advent of agentic AI, we are witnessing a fundamental shift toward intelligent systems that can perceive, plan, and act autonomously. Agentic AI represents a paradigm leap. These systems are not just reactive, they are proactive. They understand goals, reason through options, and take initiative, transforming decision making in fields like business, healthcare, and finance. Their ability to navigate complexity and context enables them to execute sequences of tasks without constant human oversight. This change introduces powerful opportunities and equally important challenges. As AI agents become more sophisticated, we must consider how they align with human values, who is accountable for their decisions, and how they affect our trust in intelligent systems. In this presentation, we'll examine the core capabilities of agentic AI, ethical and societal implications, and what this evolution means for our relationship with technology. This is not just a technical revolution, it's a reimagining of human machine collaboration. Let's now define what we mean by agentic AI. At its core, agentic AI refers to intelligent systems that don't just follow instructions, they act with autonomy, purpose, and adaptability. These systems are capable of analyzing situations, making judgments, and executing actions with minimal human oversight. One of the defining features is autonomous decision making. Unlike traditional AI, which relies on constant input, agentic systems can independently assess conditions and decide the best course of action. Another key trait is goal oriented behavior. These agents understand objectives and plan optimal strategies to achieve them, making them ideal for long term, complex tasks. Next is contextual understanding, a vital capability that allows agents to interpret nuanced environments. Whether it's a change in user behavior, market conditions, or sensor data, agentic AI adapts in real time. And perhaps most importantly, these systems engage in continuous learning. They improve with experience, refine their strategies, and grow smarter over time. In summary, agentic AI isn't just about automation, it's about intelligent autonomy. These systems are collaborators, not tools. They act on our behalf, engage actively with the world, and evolve to serve defined goals more effectively. To fully appreciate the significance of agent AI, we need to understand how artificial intelligence has evolved over the decades, from passive systems to truly active decision making agents. We began with reactive systems in the 1950s through the 1990s. These early AI models were rule based, responding to specific inputs without any memory or contextual understanding. They were predictable, but limited in flexibility. The machine learning era followed in the 2000s and 2010s. Here, systems could learn patterns from data. However, they still required explicit human direction to operate. They could recognize, but not independently reason or act. Then came conversational AI, roughly between 2010 and 2020. Natural language interfaces like chatbots emerged. While more user friendly, these systems were still largely reactive, responding to prompts without true autonomy. Now we've entered the era of agentic AI, intelligent systems capable of independently planning and executing complex, multi step tasks with minimal supervision. They're proactive, adaptive, and goal driven. This shift isn't just technical, it's conceptual. Thanks to breakthroughs in large language models, reinforcement learning, and neural networks, AI can now reason, adapt, and make decisions. We're no longer programming machines, we're collaborating with them. To function effectively, agentic AI systems must master four interconnected components: goal setting, planning, execution, and learning. It all begins with goal setting. The AI interprets high level human objectives, often vague or abstract, and translates them into specific, measurable targets. This is where intent is transformed into action. Next is planning. The system creates a multi step strategy to achieve its goal. factoring in resources, dependencies, and contingencies. It's not just about figuring out what to do, it's about designing a robust path that can handle uncertainty. Then comes execution. The agent acts on its plan step by step while constantly monitoring progress. If it encounters obstacles, it adapts in real time, adjusting its path without external intervention. Finally, we have learning. Agentic systems continuously refine their understanding based on feedback and outcomes. Successes reinforce effective behavior, while failures become learning opportunities. Over time, this feedback loop makes the system smarter, faster, and more reliable. Together, these four capabilities make agentic AI truly dynamic. It's not just automation, it's adaptive autonomy. The ability to define goals, chart a course, act independently, and evolve from experience is what sets agentic systems apart from traditional AI tools. Agentic AI is no longer a theoretical concept. It's already transforming how industries operate by taking on complex, goal driven tasks with minimal human intervention. In healthcare, agentic systems are becoming trusted assistants. They can autonomously order diagnostic tests, interpret results, and even recommend treatment plans, freeing up physicians to focus on patient care. Use cases include managing medication for complex cases, monitoring patients remotely in real time, and optimizing surgical planning. In business operations, these agents are optimizing efficiency at scale. They're managing supply chains, adjusting to disruptions in real time, negotiating contracts, and allocating resources based on evolving market demands. This includes automated inventory control, predictive maintenance for equipment, and dynamic pricing strategies based on customer behavior. In the realm of personal productivity, agentic AI serves as an intelligent digital assistant. These systems help users prioritize emails, schedule and prepare for meetings, synthesize research, and even draft documents, acting as a proactive co-pilot in daily life. Beyond these areas, agentic AI is making strides in finance, logistics, education, and government. From anomaly detection in markets to emergency resource allocation, these systems are reshaping decision making and execution across domains. As agentic AI systems gain more autonomy, they also raise profound ethical concerns. When we delegate decision making to machines, we must ask, where do we draw the line? First, we face questions about authority boundaries. In high stakes domains like healthcare, finance, and public safety, how much control should AI truly have? When must a human stay in the loop? Preventing harmful overreach means clearly defining the scope of AI authority. Next, we must establish accountability frameworks. If an AI agent makes a mistake or causes harm, who is held responsible? The developers? The users? The organization? As AI agents take consequential actions, it's essential we create mechanisms for recourse, liability, and legal clarity. Finally, there's a pressing need for transparency requirements. Users, regulators, and affected individuals need to understand how AI agents make decisions. What was the reasoning behind a particular outcome? How explainable is the model's logic? And what level of disclosure should be required? Without thoughtful oversight, we risk creating systems that are powerful but unaccountable. Ethical deployment of agentic AI demands override controls, inspection tools, and alignment safeguards. We must design these systems with responsibility and human values at their core. While agentic AI holds great promise, building truly reliable systems comes with major technical challenges. At the base lies the technical foundation, the architecture and machine learning models that power these agents. Without solid engineering and dependable infrastructure, all higher level functionality collapses. Next is computational efficiency. Agentic systems must manage large scale tasks without overwhelming available resources. Efficient algorithms, memory handling, and latency management are critical for real world viability. Then we face the challenge of robust reasoning. Agents must go beyond surface level pattern recognition and develop causal understanding. Can they reason through complex environments? Can they handle edge cases or adversarial inputs? These remain open problems. Value alignment is another major hurdle. Aligning AI behavior with human values is far from straightforward. Misalignment can lead to specification gaming or unintended outcomes. Approaches like constitutional AI and reinforcement learning from human feedback are actively being explored to address this. At the top is safety and reliability. Even if an agent is capable, it must operate within safe bounds. Predictability, fallback mechanisms, and error containment are essential, especially in high risk environments. Together, these layers remind us building agentic AI isn't just about autonomy, it's about trust, control, and resilience. Let's now look at how agentic AI is performing in the real world through a few case studies, highlighting both its successes and limitations. At the Mayo Clinic, a diagnostic assistant was deployed to support medical decisions. Its success was attributed to a gradual, carefully validated expansion of AI authority, always with clinical oversight. This phased approach allowed trust and effectiveness to grow in tandem. Global retailer X used Agentic AI for inventory management. The system delivered success by combining transparent decision logic with human review checkpoints. It optimized supply chains while keeping critical stakeholders in the loop. In contrast, financial firm Y deployed an AI driven trading algorithm that failed. The issue? The system lacked robust safeguards for unusual market conditions. Without scenario testing and adaptive controls, the agent made confident but costly mistakes. Finally, City Government Z implemented an AI system for resource allocation. Results were mixed, with effectiveness varying based on the complexity of each domain. This highlighted the importance of domain specific tuning and oversight. These cases reveal a clear takeaway. Successful deployment of agentic AI depends not only on technical capability, but also on thoughtful design, staged rollouts, and continuous human supervision. Balance, not blind automation, is the key to trust and performance. As we look ahead, the future of AI isn't just about machines acting alone, it's about how humans and AI collaborate. This slide outlines four key models on the spectrum of autonomy. At one end, we have AI as tools. These are systems that extend human capability but require constant guidance. They're fast, accurate, and powerful, but passive. Moving up, we encounter AI as assistants. These systems proactively suggest actions or insights, but humans stay firmly in control. Think of them as co pilots, helpful, but not fully independent. Next is AI as partners, a model of equal collaboration. Here, humans and AI share responsibilities and contribute complementary strengths. Humans bring creativity and judgment. AI brings consistency and scale. Finally, there's AI as autonomous agents. These systems operate independently with limited oversight, especially in structured domains like logistics, planning, or infrastructure. They plan, decide, and act at scale. Different domains will adopt different models based on context. In sensitive areas like healthcare or criminal justice, human oversight is critical. In well structured environments, more autonomy may be appropriate. The future of agentic AI lies in choosing the right collaboration model, one that balances innovation with responsibility and automation with trust. As agentic AI continues to evolve, preparing for the future requires more than just technological advancement. It demands a coordinated response across education, policy, and workforce development. First, education transformation is essential. We need to develop curricula that emphasize human centric skills like creativity, emotional intelligence, and critical thinking that AI cannot replicate but can complement. These uniquely human abilities will be critical in an agentic future. Next, we must build regulatory frameworks that are adaptive and forward thinking. Governance structures should ensure safety and fairness without stifling innovation. The goal is to enable responsible AI deployment while preserving public trust. In parallel, workforce evolution must be supported. As AI automates routine tasks, we must also create new opportunities for collaboration between humans and AI. This means reskilling and upskilling workers to take on roles that involve oversight, strategic thinking, and system supervision. Finally, global coordination will be key. AI knows no borders. International standards and cooperative policies are necessary to manage the risks and opportunities posed by increasingly capable agentic systems. In short, preparing for the agentic era is a multidisciplinary challenge and an extraordinary opportunity. Those who invest in readiness today will be best positioned to thrive in the intelligent systems economy of tomorrow.